Hello developers, let's continue developing. So, this is the second part of day 19 of 2024's Advent of Code. My name is Veko and we're gonna continue with our solution. So we solved the first part using a lot of recursion. We actually added some caching, so it was possible to evaluate everything just a bit faster, like a lot faster. And the second part, but in the first part, we only needed to check the existence of something. So if a combination existed that can generate this, it's great, and we're done. But in the second part, we actually have to count the ways in which this can be done. So in principle, it's gonna be identical, except it's gonna be totally different. The main loop is exactly the same. We're looping through each design. We're counting the combinations now. We're not counting the true or false. And we're adding them to the total. But in each of the sets of recursion, we kind of have to do it a bit differently. So I will set the initial value. Here we set the zeroth value at true. So here we will set the initial value. So if we have an empty string, that means that we can define that design with a single pattern, and that's basically the empty pattern. We're going to count that as 1. Otherwise, if we already have a value for our design, we're going to return that. So this is a number. Otherwise, get all the applicables. And now this part will be quite different, because previously, when we checked existence on the first item that we got a hit, we can just return true and we're done. But now we will have to actually take this out of the loop and have a total count. These are the total number of combinations for all of the applicable patterns. So now for each of the applicable patterns, we will need to count the current number of combinations for that specific pattern and add it to the number of combinations, which is not going to be constant. And once we're done, here we had the condition. Then if we got here, that means we have no applicables. But now it doesn't really matter if we have applicables or not, because the result of nothing applicable will actually be 0. So we're gonna say for that design we have this many combinations, and then return the number of combinations. So this might work. We have the small input here. By the way, this will either be a very short video or a very long video, and I have no idea which. I mean, I think at this moment you know better than me, because you have that thing, that the bar. So if the pointer is over in this part, or over there somewhere, yeah, it's a long video, but if it's over here, it's a short video. I don't know, you know better than me. So let's start it and let's see what we get. We should get 16, I think. And we're getting 2 combinations, 1 combination. Let's take a look. 2, 1, 4, 6, 1, 0, 1, 2, 0. Looks correct. Let's take the huge input and put it on. And I hope that we get a correct value. 402 items. Let's run it now. And the result is, what kind of number is this? This is 1000, million, billion, trillion. The total number is 800 trillion. If we needed to count them one by one, that would have been a long count. But we are correct. So we managed to count all the way to 800 trillion and got a star for that. But only by avoiding counting things that we already counted. So in a lot of places we actually did some additions. So this is the number of unique ways that we can convert those things. Wow, that's a big number. It would have taken us a while to count to that. Anyway, thanks for watching. Click on the buttons, leave a comment, don't click the bad button, and keep developing.